Okay.
It was depressing.
All right.
It was also winter.
Short class today. We're going to pick up on page 183, the transfer of heat. We're going to try to get through it in this class setting. I don't know if we'll make it or not. If we don't, they're going to finish reading it on their own, and you can do the same. No homework questions, okay? This is just, again, because of ERBs, I'm trying to cut down on the amount of homework that you have on any one day. All right. And this class is over at 11 o'clock, which is almost 11 o'clock. All right. Have you ever seen a blacksmith work? Okay, this guy, you know, I mean, he is, I'm sorry, that's good. So you've seen it, okay? So that's good, you've seen it. Okay? It was a rhetorical question. It was not I don't need the whole rundown. I would love to hear it sometime, but not right now. You see that guy, he's standing there holding, and you know, I think blacksmith, I think about horseshoes. Of course, they do all kinds of other stuff. But the first thing that pops in mind, your horseshoe. And he's standing there, he's got the forge that he's holding over that hot, it's raising fire. And he gets that thing that's red hot, and then he pulls it out, he puts it on the anvil, and he can take that hammer and he can shape that metal to whatever he wants it to be, because he has gotten it so hot. And then he puts it in the water, and it instantly cools it and hardens it now into the shape that he has put it into. Okay? So all that, though, to say that is because that blacksmith is experiencing the three different types of heat transference. Okay? He will transfer three ways. Okay? Conduction, convection, and radiation. And that blacksmith is experiencing all three of those as he is working. Okay? Conduction, in the process of conduction, heat is actually transferred from one particle of matter to another without the movement of the matter. Okay? Think about a metal spoon in a pot of water on an electric stove. Okay? The moving particles in that hot electrical core collides with the slow-moving particles in the cool pot. Okay, that transfers that heat, causing the pot particles to start moving. Okay, so they're starting to warm up, and as it starts to warm up, now it starts to transfer its heat to that metal spoon, which is why if you walk up and grab hold of that and it's been in that boiling water for a while, you will pull your fingers away rather quickly because it will burn them. Have you ever done that with hot chocolate? You get a nice hot chocolate, you put a metal spoon in and stir it up, and then maybe you go mess around for just a few minutes, and you come back and you reach in to grab the spoon, and the spoon is kind of like, oh, it's a little warm.
That's what happens when I
the hot chocolate, yeah,
out of the dishwasher.
Exactly, yeah. The hot chocolate has transferred its energy, the heat, to that spoon. What? Same thing with the Coke in the cooler. Exactly. Exactly. Exact same thing. Okay? All right. So that is conduction. Now, convection, some of you have seen these, they've got these ovens, the air oven things, that warm air, and the way it circulates. And that's kind of what this is, okay? If you watch a pot of hot water on a stove, you will see water moving. And if you've ever boiled water, you will. It will get to bubbling, and then it really gets to churning in there pretty good, the hotter it gets. Okay? The movement transfers heat within the water. In convection, heat is transferred by the movement of current within the fluid. Okay? When the water at the bottom of the pot is heated, its particles move faster. The particles also move farther apart as a result, and the heated water becomes less dense. Okay? And if you remember, less dense fluid will float on things that are more dense. Remember the experiments we did? So the surrounding cooler water flows into its place, and basically it rotates. Okay? The hot water, the water gets hot, it moves up, the other water comes down because heat rises, and it's just that constant movement. Okay? And that is what convection is. Okay? Radiation is the transfer of energy by electromagnetic waves. You can feel radiation from a fire in a fireplace all the way across the room. Okay, you don't have to be standing right up to it, If you got that thing going really well, it'll warm up the entire room, right? And you can feel the heat, okay? Unlike conduction and convection, radiation does not require matter to transfer the thermal energy. All the sun's energy that reaches Earth travels through millions of kilometers of empty space, okay? And it still gets here and warms us up, okay? Now, we're talking about how heat moves one way, okay? Now, by moving one way, it can go in a circle, but it's only moving one way, is what it's saying.
You can't go
Okay?
backwards.
Yeah. It doesn't turn around and run backwards, okay? That's what it's trying to say. If two objects have the different temperatures, the heat will flow from the warmer object to the colder one. That's what we have talked about. There's no such thing as coldness, okay? Nothing gives off coldness, okay? In order for something to warm up, whatever is warmer is actually transferring its heat to the cold item, trying to warm it up to where it's at. And by transferring that, you are warming that up a little bit, but in the meantime, whatever is transferring that heat is cooling down. Okay, it uses an example of an ice cream. If you've ever made homemade ice cream in one of the old crank thing where you actually put the salt and ice and whatever flavoring you want and all that stuff in there, and then you crank it and crank it and crank it and crank it. That's how you made homemade ice cream back when I was a kid. Yep.
That sounds cool.
Yeah, they did. They electrified them even
No, I mean like
later
not,
on. But,
not like that kind of churn. Like,
yeah. Yeah, what is exciting though? Because that, as a kid, you used to love to be able to give her and crank that thing for. It felt like hours, but
When you
you
get
know, you would
older,
wear out
it's
in
like-
about 30 seconds. Because that's hard work. Okay. All right. Anyway, but again, there's no such thing as coolness. Instead, the ingredients in when you're making ice cream grows colder as the thermal energy flows from them to the ice. Okay. So it's actually cooling it down to that same temperature is what's happening. Then you've got conductors and insulators. You've all done this before, I feel confident. You know, you jump out of bed onto a rug and it's nice and warm. And then maybe you step out onto a tile floor or a wooden floor, and yeah, and all of a sudden it feels colder. But the truth is, they're both room temperature. Whatever the temperature is in the house, both of those are that temperature. One is an insulator, one's a conductor. That's the difference, okay? A conductor transfers thermal energy well. An insulator does not transfer thermal energy well, okay? A conductor is something like, okay, a material that conducts heat well is called a conductor. Metal, like silver, stainless steel, are good conductors, okay? A metal spoon conducts heat better than a wooden spoon. Okay? Some materials are good conductors because of the particles they contain and how those particles are arranged. A good conductor, such as a tile floor, feels cool to the touch because it easily transfers heat away from your body, okay? From your skin, okay? Now an insulator, a material that does not conduct heat well, is called an insulator. Your home is insulated. The walls, the ceiling, the flooring underneath, all that has what they call insulation in it, and that is to keep the heat from being able, and the air from being able to just escape. Okay, it helps keep it in, keeps your house warmer and cooler. Okay, cuts down on the power bills. Wood, wool, straw, paper, all of those are good insulators. So are the gases in the air. Clothes and blankets are insulators. Okay, they slow the transfer of heat out of your body. Okay, a well-insulated building is comfortable inside, whether it's hot or cold outdoors. Okay, insulation prevents heat from entering the building in hot weather and escaping in cold weather. Much of the heat transferred in the building occurs through the windows, and for this reason, insulating windows have two panes of glass, and then they have a thin space of air in between them, okay? And that's the biggie now in homes and all, because when I was a kid, you just had that one pane of glass, and you could actually walk up on a cold day and put your hand on the glass, and it was just, it was just cold. You do that now on the inside, and you're just leaving a handprint, but most of the time, the glass feels pretty much the same temperature as the inside of the house, because it's well insulated, okay? Now, a blanket, think about a blanket when you cover up, okay, that is a, yeah, that's, you cover up in a blanket. What it's doing is keeping the heat in, okay? It doesn't keep it all in, but it keeps your body temperature from escaping out past the blanket, but it's going into the blanket, and it's keeping you warm, and it's warming you up. And that's how all that works, okay? We are almost through with in the book. I'm going to start handing out. We've got a couple of very short handouts that we will do eventually. That's where your homework comes from. There's only 2 homeworks. And that's going to count as your quiz also, so you're going to do well on the homework, okay? I will remind you again. Okay, about 11.5 minutes. That's not too horrible. And now you don't actually have to do the reading if you don't want to. Some interesting stuff, but that's entirely up to you. No homework question, nothing on the test is going to come from this reading. Thank you. Bye.